Hello, good evening, what's up, and welcome to Module 2, Video 2 in our online video tutorial series. My name is Brock Grant, and today we're going to be going through matter, elements, and compounds, and trying to answer some questions that may appear in your exams. So, just a quick prerequisite for this module, please make sure that you just go through Video 1, Module 2, Matter, Elements, and Compounds, and just make sure that you're familiar with the lecture content or what was covered in the previous video. So today we're going to be covering Chapter 3 and Chapter 4. So these will be on pages 12 and 74, questions 12, 25, 29, and question 8. So let's start on page 58, question 12. So the question is asking how many oxygen atoms are represented in each of these formulas. So let's look here. So we've got Fe, which is iron, we have carbon, hydrogen, and oxygen. So the first thing we need to do is pay attention to our brackets and our subscripts down here. So we can see the only oxygens that are in this formula are within these brackets. So we have 2 oxygens in here, and everything that's inside these brackets is multiplied by 3. So that means we have 3 lots of O2, meaning that we have 6 oxygen total. So the second one, we can see too that there is no coefficient at the front. So because there's no coefficient at the front, we simply assume that it's 1. So we have H3PO4. So the answer for that one is 4 oxygen. And the lucky last one, Fe2Cr2O7, and again we've got our brackets, so we need to be aware of that. So we've got 7 oxygens, then that's multiplied by 3. So 7 times 3 is 21, so we're going to have 21 oxygen molecules. Okay, so page 58, question 25. Consider a homogeneous mixture. So what we're going to do is we're going to underline homogeneous because that's important. Mixture of salt dissolved in water. What method could you use to separate the 2 components of this mixture? So what's very important here is we need to think of a couple of things. So the first thing that's grabbing my attention is homogeneous. So that's telling me that the salt and water are mixed in a solution and it's consistent throughout. So it's not like we have a big clump of salt at the bottom and the rest is water. So it's not like it's like this and we're going to have like sort of all of our salt clumped down at the bottom. No. What's actually happening is we've got our glass of water and the salt is just mixed through here consistently. So what method could we use to separate the 2 components of this mixture? So what we can do is we can just simply boil it. Now what's important here is that when we put salt in water, it is a physical change. It is not a chemical change. And the reason for that is because this is reversible. Okay, and that's a very important distinction between a chemical and a physical change. Now think of it as like baking a cake, for example. So when we bake a cake, that is a chemical change because it is non-reversible. You cannot get a cake and put it in some sort of anti-oven and get it to rewind back so we have our original ingredients. It doesn't work like that. However, with our salt and our water, if we were to put that into a saucepan and boil it, we can then boil off our water out here, leaving us with just our cup of salt. Okay, let us move on now to question 29, page 60. How many total atoms are present in the following compounds? So we can see here we have oxygen, we have manganese, and we have potassium. So we have 1 potassium, 1 manganese, and 1 oxygen. So, or 1 group of oxygen, I should say. So we have 1 potassium, 1 manganese, 1 lot of O4. So that means that there is actually 4 oxygens, meaning that we have 4, 5, 6. We have 6 atoms total. So looking down at the next one now, we have Fe3. So we've got 3 lots of iron. And then we've got PO4, 2. So we've got 4 oxygens and 1 phosphorus, so that's 5 atoms total. And because we've got our little subscript here, so all of this is times 2. So that's going to be 5 times 2, which is going to equal 10. So it means we have here, we have 10 atoms, and here we have 3. So we're going to have 13 atoms total. Okay, so let us move on now to question 8, page 74. State whether each of the following represents a chemical change or a physical change. Now, this type of question here is a very, very popular exam question. It's very easy for us to ask, and there are plenty of different scenarios that we can think up of. So please make sure that you are comfortable in identifying a chemical or physical reaction. And if you're not, it will be definitely worth your time to rewind back to the previous video and check it out. So let's look at question A here. So a few grams of sucrose, so that's just normal table sugar, are placed in a small beaker of deionized water. So when it says deionized, all that means is that it is only water. It's pure water. There are no, there's no chlorine or any other ions that may that's often used in the water cleaning process. So we have just a cup of pure H2O. Now, the sugar crystals disappear. So I think a better word for that would be dissolve. So the sugar crystals dissolve and the liquid in the beaker remains clear and colorless. So now we've got to think to ourselves, is this a chemical change or a physical change? So a couple of questions that we ask ourselves is, 1, can we reverse this? Is there something that we can do to separate the water and the sugar again? And the answer is yes. We can simply boil that water off. We see this a lot in cooking when you're sort of caramelizing something. That's when we're sort of removing that water, and that's how it gets very, very sticky. So if we bubble off this water, we're going to then have a reduced amount of water, and then we're going to see our sugar come back. Another thing too that we can ask ourselves is, did we change the sugar in any way? So did we change the sugar down into something else? Did we break it down? Did we build it up and make it into something new? The answer is no. Okay, all we have is just sugar and water. So the answer to A is physical. So let us look now at the next one. So when a teaspoon of baking soda, so sodium bicarbonate, is placed into a few ounces of vinegar, so acetic acid, volumes of bubbles are produced. Okay, so a couple of things are jumping out at me here again. The first one, and this is probably the most important, is volumes of bubbles are produced. Produced is the key word here. Okay, so when it said produced, it meant we had our sodium bicarbonate, we had our acetic acid, we mixed them together, and something was produced. We made something from it. Now, these bubbles here, which is CO2 gas, which you don't need to know, don't worry about that, but they didn't just appear. And we're going to cover that more through subsequent modules, but atoms, energy, anything doesn't just appear magically. It must have occurred due to some sort of reaction. So the fact that bubbles were made, and also the fact that we had a sodium bicarbonate, which is a base, and we had our acetic acid, which is an acid, also tells me that a reaction will take place. Now, you are going to cover acids and bases more in your second semester chemistry subject, so don't worry too much about delving too deep into the reaction of acids and bases, because that's not important here. But the thing is that we can see that the baking soda and the vinegar reacted and created these bubbles. So we know now that C is a chemical change. Okay, so this wraps up Video 2, Module 2. Thank you all very much for joining me today. If you have any questions, queries, suggestions, anything like that, you can feel free to email me at b.grant@griffith.edu.au, or feel free to throw a comment down in the comment section below, as I will be checking those frequently, and I'll try to help you out as much as I can. If you could all please do the survey that I'm going to put a link for down in the description, that would be fantastic, as again that helps me to sort of reform these videos and make sure that they are a useful resource for you. Thank you very much for joining me, and I'll see you next time.